Hello and welcome you all. Today's video we are going to solve one problem asked in CSIR NET December 2016, and actually it is a problem from a very important and favorite topic of CSIR NET or GATE exam, which is called uniform convergence. Okay, in this problem they have given us four series. Okay, in fact four series of functions, and they are asking which of the following series is or are uniformly convergent in the given interval. Here the interval is open interval minus pi to pi. Okay, look at, to solve this problem you should have a clear idea about Weierstrass M test. Weierstrass M test for series of functions, okay, which says that suppose you have the series summation fn x where n runs from 1 to infinity, and your interval say d, that means x belongs to d. Then if the question is to check whether this series is uniformly convergent or not, then simply you need to find this kind of relation. First of all, that means mod of fn x less or equal to some mn, where this mn is a sequence of positive real numbers. Okay, and if this series converges, then this Weierstrass test says that your series, that means this series is going to be uniformly convergent on, okay, if that one holds, then your series is going to be uniformly convergent. Okay, that is the basic idea of Weierstrass M test for series of functions. Okay, we are going to use this result or theorem to solve this problem. Okay, so now come to the first option, where they have given us series e to the power minus n mod x by n cube, n from 1 to infinity. Okay, so definitely here your fn x is going to be e to the power this way, and simply you can write this one as this way. Now take the modulus, and immediately it is clear that this part 1 by e to the power something that is less than 1 and multiplied with n cube. Okay, that means mod of fn x is less or equal to 1 by n cube. Okay, so your mn, that criteria, your mn should be 1 by n cube, and from the previous discussion you need to check whether this mn, summation mn, is convergent or not. Obviously it is convergent by p test. Here p is equal to 3 and it is greater than 1, so by p test your series mn is going to be convergent, and by Weierstrass M test you can immediately conclude that your series of function is going to be uniformly convergent on your minus pi to plus pi. Here the interval doesn't matter here, in fact. Okay, thus our first option is correct and it is uniformly convergent. Now come to the second option. In the second option, they have given us summation sine xn by n to the power 5, and it is also very straightforward, you can say, because your fnx is sine xn by n to the power 5. Take the modulus and it is 5, and you know that mod of sine xn, the maximum value will be 1, so it is less or equal to 1 by n to the power 5. Okay, and by the previous logic you can say this is your mn, and clearly your mn is going to be this kind of series, and by p test it is also convergent. So your main series of function is going to be uniformly convergent by Weierstrass M test on this interval minus pi to pi. So the second option is also correct one. It is also uniformly convergent. Now come to the third option. Here in the third option they have given us x by n whole to the power n from 1 to infinity. Now your fnx is x by n whole to the power n. Okay, and take the modulus, and this is going to be x by n whole to the power n, and here x belongs to minus pi to plus pi in this interval. So you can say mod of x is less than pi. So we are going to use this, and we have this kind of thing in our hand. So it is going to be pi to the power n, n to the power n. All right, this is nothing but pi by n whole to the power n. All right, so we have fnx is less than pi by n whole to the power n. So our mn is going to be this. Now the next job is to check whether this series is convergent or not. For that purpose you can immediately use Cauchy root test, and it will be mn whole to the power n. Take the limso as n tends to infinity, and you have pi by n tends to infinity, so it is going to be 0, and this is less than 1. By Cauchy root test you can conclude that this series is going to be convergent, and it is convergent means our given series of function is also uniformly convergent in the interval minus pi to plus pi. Clear? Just simple use of Weierstrass M test and a very basic result from real analysis, which is Cauchy root test, we have used to tackle this option. Okay, thus third option is also uniformly convergent in that interval. Now come to the last option, where they have given us the series 1 by x plus pi into n whole square, n from 1 to infinity. Okay, this series is given to us. Now this series is given to us. Now just the same process we have to follow, and it is f(n)x, it is going to be like this way. Take the modulus, and you have 1 by, just write it down like this way. So this is square and this is n square. So you have x plus pi square, just writing it like this way. Okay, no problem. Now immediately it is clear that this is going to be our mn, and we need to check this series. So this is going to be, in fact you can write like this way. This will come out as there is no n, and you have this kind of stuff. Clear? Just take the summation both side, and this part, it is independent of n, so it just comes out, and you have this kind of series. And look at this series, that means 1 by x plus pi square to summation 1 by n square, n from 1 to infinity, and this series is convergent by p-test. It is convergent, that means it will give us a finite quantity or finite number. Alright, but what about this term? Look at, your interval is minus pi to plus pi. Whenever x tends to minus pi, then x plus pi, this term, that means this term is going to 0. It has a tendency towards 0. That means 1 by, in that case 1 by x plus pi whole square, it is going to infinity. In fact, it is turning out to be an unbounded quantity, isn't it? Because the finite quantity here, no problem, but whenever x tends to minus pi, then this term will go to infinity. Thus you can say this series will be divergent in that case. Clear? And immediately you can say this given series of function is not uniformly convergent. Okay, thus your fourth option is a false one, and remaining third option, means 1, 2 and 3, these are the correct options. Okay.